Let me share my screen. Good morning, people. So today's session is about introduction to big data processing using Spark. And myself and Pravitha will be taking the session. I'm Anusuya. I have been working in ThoughtWorks for past 3 years, working here as a developer. Pravitha, do you want to introduce yourself?
Yes, Anusha. So I'm Pravitha. I have been here in ThoughtWorks for 1.3 years and I'm working as a developer. Yes, Anusha, you can carry on.
So, yeah. Before starting with the agenda, right, we already sent the prerequisite. If anyone joined without registering in Meetup, right, we shall share the drive link here. The prerequisite is you should download Anaconda Navigator for hands-on session, and we have some sample notebook and dataset there. You can refer the drive. The link is shared in the chat by Pravitha. And also it will be good if you all turn on your video. It will be more interactive. So please feel free to ask the questions in your chat or stop me in between if you have any questions. We shall get started. So, agenda for today's call is like we will be going through introduction to big data, Spark ecosystem, like what are all the modes of running Spark application, fundamentals of RDD, and a small hands-on exercise in RDD, and then data frame basics, again a hands-on exercise in data frame, and then finally we will be doing a demo on how to run a Spark on Dataproc cluster. This is what we planned for today, and the estimated time is 2 hours. We shall get into the agenda. Yeah, introduction to big data. We'll start with the data quantity fact. So every minute, right, this is what some rough estimated data volume. The world produces 100 million gigabytes of internet data. So here I have stated few facts which are every minute data, and 58,300 trips are started with Uber. And also in Twitter, right, 4,74,000 tweets are tweeted. These are some of the sample data quantity fact. You can take this as a sample and you can imagine like what are all the applications we are using, right, in our day-to-day life, and what amount of data we are dealing in our day-to-day life. So what is big data, right? Big data can be defined with these three V's. One is volume, next one is velocity, third one is variety. What is volume? Like the data, whatever we are having currently or whatever we had in 2009 and data we are having today, right? There is a tremendous increase in the data volume. That is what the rapid increase in the data, right? That is what the volume is. And variety, and the data whichever we are receiving from the source system, right, is not always of same format. So we can segregate the data format into three types. One is structured, next one is semi-structured, number three unstructured. What is structured data, right? It is having definite schema. For example, the data whichever you can populate into RDBMS system, right, that is an example for a structured data. It is having strict schema. But as part of semi-structured, right, the schema is not very strict. For example, you can able to derive the schema out of the data. For example, JSON, CSV, or few examples for semi-structured data. And in case of unstructured, right, you can't even detect the schema from that file. For example, images or video, audio file, whatever you are having, right, those are all an example for unstructured data. And velocity is at what pace the data are receiving into our system. For example, the mails whichever we are receiving in our day-to-day life, or the tweets we are receiving, right? These are all few of the examples for velocity. And later on, two V's added to this big data term. One is value, another one is veracity. Value is like what meaning we are going to derive out of the data. It will be meaningless if we have GB or TBs of data in our system, but we can't derive any insight out of it, right? So, what is the meaning we are going to derive out of the data? That is what value. And veracity is uncertainty or inconsistency in the data. If you see, take this minimum column, 4.3, 2.0, 15,000 and 0.1. Here, this 15,000 looks like odd one out. By seeing this itself, we can see there is some mismatch or inconsistency in the data. That is what veracity is. So these five terms defines a big data. And what is big data engineering, right? If you are able to design a system with all these five capabilities, then that is called big data engineering. Scalability is the volume of data you are having currently and the volume of data you will be having in your near future will not be same always, right? So your system should be able to scale accordingly based on your data need. And fault tolerance, say if something got corrupted or crashed, then how will you have that fault tolerance in your system, right? That is so your system should have fault tolerance capability as well. Resiliency is bringing back the system to its original form. Say some um, system down or something went wrong in your system, so how will you make your system to the original form? And debugging ability, if your data got corrupted, how do you know like which data corrupted and what makes the data corruption, right? If your system have the debugging ability, then only you will be able to know that. So your system should have this capability as well. And then maintainability is your system should alive until the application alive. So if you are able to design a system with all these five capabilities, then that is called as big data engineering. Is data engineering always big? Not always. And this is an example of big data ecosystem. If you see here, right, the tools whichever shown in the image, these are all the tools whichever we are using for processing big data. So it will not be quite feasible to learn all the tools whichever shown here, right? So how can we learn that, right? So starting from analyzing or onboarding the data to platform and creating some kind of visualization from that, right? The process is splitted among these five lanes. One is data strategy, another one is data platform engineering, then machine intelligence, data insights, and user experience around insights. So data strategy is, let's take an example. Let's say there is an organization. In that organization, you want to identify like what is the gender parity, men women ratio, right? Then you should know like whatever data available in your hand, will you be able to derive that insight or not? And like who should have access to what? Everything will come under this data strategy part. And in data platform engineering, like you should be going to build a data platform. From this platform only, like you will be creating insights. And machine intelligence in this part, right? You will be integrating this with data platform engineering to run some machine learning algorithms. And in data insight part, like you will be making some decision based on the insight you created from the machine learning algorithm you used, right? You will be getting some pattern or some insight from the data, and from that you will be taking any decision. And user experience around the insight is like whatever decision you make, right? You are going to represent that as an visualization tool. That is what will be done as part of user experience around insights. So we will be classifying the whole journey across these 5 lanes, right? And the tools whichever we are using for each one might be different, but the logics or the things behind each tool will be similar. Okay, so these are all some of the examples for each stage. If you take this data strategy, like metadata management, like what are all the data we are having in our platform, or who should have access to what, that security control, data access will be part of data strategy. And the part of data platform engineering, right? Like storing the data to platform and data integration and processing the big data, orchestration and workflow management will be part of data platform engineering. And in machine intelligence, like integrating models with data platform and tracking the models whichever we are going to use, right? Everything will be part of machine intelligence. And in data insight, like we will be writing advanced queries on top of the data, and we will be creating some insights. In user experience around insight, like we will be using any visualization tools like Sizens or Tableau, and we will be representing the data or insight whichever we created in some good manner. Yeah, these are some of the example for big data tech stack. So for data storage, we shall use GCS bucket or S3 or HDFS. And for data transformation and integration, we shall use Kafka, Spark. And then workflow management and coordination, we can use Airflow, Uzi, or any of these tools. In today's session, right, we will be deep diving into the Spark. And this is not for advanced learners, this is for beginners. So we will be covering the basics of Spark in this session with some hands-on. So for any doubts, people? Taking it as no, we'll move on to the next part, Spark ecosystem.
Anushya, like why we are preferring for Spark among other tools?
We are not preferring Spark, like we can use anything, but in our session, right, today we are focusing only on Spark.
Okay, thank you.
And market is also like nowadays MapReduce and all we are not using. Most of the people are using Spark only due to its performance.
Okay, thank you.
So let's see Spark ecosystem. Okay, you can consider this like a solar system. Okay, so this one, right? Spark's native language is written in Scala, but you don't need to write your application everything in Scala. Spark supports many languages. Few of those are Java, Python. Those are few languages. So you can write with whatever languages you are familiar with, and internally Spark will convert all the things to Scala and do the internal processing. And also it supports provide lot of API support for machine learning library and streaming. Streaming is for processing the real time data. For example, let's take some credit card example. So you are doing some transaction, and you want to set an intimation. If you spend around 1 lakh, right, you want to get some notification kind of thing. If you want that, the processing should be near real time, right? Then only this can be achieved. So for those needs we can use the streaming API. And SQL API for processing the SQL queries. And for graph database, we can use GraphX API. And we can deploy the Spark application in different modes. I will explain those in the upcoming slides. So how do we execute programs on Spark cluster, right? There are two ways. One is interactive client, another one is submit a Spark by Spark Submit utility. For this one, we took an example of running the Spark application in Dataproc cluster. That one will be demoed at the end of the session by Pravitha. And this interactive clients, right? Either we can use Scala Shell or PySpark or Jupyter Notebook. For this one, right, we will be having small hands-on. for production deployment, people will prefer this Spark Summit utility one. For exploration purpose, we can use this interactive clients one. How does the Spark executes our program on a cluster, right? There will be a driver and a bunch of executors which are responsible to execute our programs. Say there is an application one, and when you do a Spark Summit, right, there will be a dedicated driver and set of executor for the application. And say you are going to run another application named as A2, and if you submit that application in Spark, right, then next set of driver and executors will be created for that specific application. What I want to convey here is, like, for each application, the drivers and executors will be created individually, and these drivers are responsible for analyzing the data, distributing the data across the executors, and scheduling and monitoring the progress. So the drivers are responsible for all the four works. Now you will be having a question like who executes where. We have driver as well as executor. So who will execute where? Either in client machine or inside cluster, right? So we have two modes. One is client mode, another one is cluster mode. In client mode, the driver will be there in client machine and executors will be there in cluster. And in cluster mode, right, both driver and executor will be there in cluster. So for production environment, the preferable mode is cluster mode. Why? Because say we are having our driver in client machine and if client machine goes down, then what happened to driver, right? That is a big question. So for production deployment, we always prefer having a driver in the cluster. That is the cluster mode. This is the summary of what we saw. Like how does Spark execute our program on a cluster, right? I hope everyone is clear now. Spark creates one driver and bunch of executor for each application, and there are two modes of deployment. One is client mode, another one is cluster mode. Based on our need, we can use either client or cluster mode. And then here, who controls the cluster, right? Say there is a resource and we have a driver and bunch of executor. Then how come the resources are getting splitted, right? We can use either of these four: Apache Yarn, Apache Mesos, Kubernetes, or standalone. These are resource manager. This is independent of Spark application. Like these are kind of pluggable components. If you want Apache Yarn, you can use that. Otherwise, if you want Mesos, you can use. Based on your need and preference, you can use any of the cluster resource manager here. And there is one more mode called local mode. This is a normal, like how we are running our Java program, right? Like that we can use our local mode for any exploratory purpose or for a small data set and all. Like driver and executor both will be there in Spark JVM, and we can use our local machine for running our job. This is all about Spark. We'll move on to Spark fundamentals is over. We'll move on to RDD, resilient distributed dataset. So I will stop here for any questions.
I have a question regarding the cluster manager. So when we say we submit a Spark job, we submit the driver program to the cluster manager. Is that understanding correct?
Yes, correct.
Correct. Okay. So driver should be responsible for creating all those executors.
Driver, based on our need, right? While submitting a job itself, we can specify so that based on that, the executors will be created.
Right. So how does driver then interact with the cluster manager?
Like while starting itself, the driver will be responsible for getting the number of resources for the executors, right? So it will talk with the resource manager and get the necessary resources.
Okay. But how does driver know the location of the cluster manager?
So everything is interconnected. It is not like independent. Both are independent. Driver knows like about the resource manager as well.
Okay.
Okay, we'll move on to next part, RDD, resilient distributed dataset. RDD is a fundamental data structure of Apache Spark, and this is immutable collection of object which will run on different nodes of the cluster. There are three ways of creating RDDs in Spark. One is parallelized connection, another one is external data, and from existing RDD. External data in the sense, say you are having your data in GCS bucket or some other place, right? Or as a CSV or JSON file, then you can create RDD from that external data as well, or you can create RDD from the existing RDD. Say you are applying some logics to the existing RDD, and from that you are creating new RDD. So these are all some of the ways of creating RDDs in Spark. So these are all some of the features of RDD. RDD is basically partitioned and stored in different nodes of the cluster, and we have fault tolerance in place, and it is in-memory computation. It is not like MapReduce, it is in-memory computation, and lazy evaluation is in place. For example, unless and otherwise we are having some action on the transformation, the transformations will not execute, and it is immutable. So there are two RDD operations, transformations and actions. Transformations are the functions that produces new RDD from the existing RDD. What it will do is it will take RDD as an input and produces one or more RDD as output. Each time it creates new RDD because it is immutable. And as I said earlier, transformations are lazy in nature unless and otherwise we are having actions on it. There are two types of transformations. One is narrow transformation, another one is wide transformation. So in narrow transformation, data in one partition can process independently of another partition. Say you are going to apply one filter logic. Let's take that organization example, and we are storing employee information here. What we are going to do is we are going to filter the employee based on salary, whose salary ranges between 5 lakh to 10 lakh. Then you can apply this filter logic to each partitions separately. This is an example for narrow transformation. So these are all few examples for narrow transformation: map, flat map, map partition, filter, sample union. I will explain this wide transformation now. Then you will understand or compare these two in a better way. So in wide transformation, it will not be possible to apply some logic to one partition separately. Let us take group by key as an example. So I am going to group by salary. Then you need data in all partition in order to do the group by, right? Then data shuffling has to be taken from all the partitions. We are going to merge the data or shuffle the data, then we are going to achieve the output. This is an example for wide transformation. For example, these are some of the examples for wide transformation: intersection, distinct, reduce by key, group by key. These are few examples for wide transformation. Okay, we'll see what is action. Like actions are Spark RDD operation that give a non-RDD value. We are going to apply some action on the RDD one, and we will be getting non-RDD value as an output. It brings laziness of RDD into motion. Yes. For examples of actions are count, collect, top, or count by value. These are few example actions in Spark. Let's take this as an example, and here the first one represent log lines. Okay, so this is an RDD, and we have partitioned our data into four. We have four partition, and this log message is containing data logs of type error, warning, as well as info. Here I am going to apply one filter and filtering out only the error logs. And here next one is errors RTD, and I want to clean up the or reduce the partition count to 2, because I'm having one empty partition, right? So what I want to do is I want to remove the unused one, and I want to reduce the number of partitions to 2. Then I shall use this coalesce function in order to reduce the partition count. If you want to increase the partition count, right, you can use repartition. And here I got the cleaned RDD, and here the collect is an action here. So say or consider if you are not having this collect action, then the transformations will not taken place. So how to clean up unused partitions in the RDD, right? Either you can use coalesce function for cleaning up the partition, and for cleaning up the unused RTD, you can enable dynamic memory allocation while running the program itself, so that unused RDDs can be deleted automatically. Okay, caching RDD. Let's take, you want to do one or more operation based on the output you are getting in one RDD. Let's take this cleaned RDD and you want to do 2 operations or 2 actions here. One is count, another one is filter and collect. In that case, how Spark executes it, it always start from the first. For count also, it will start from log line RDD, error RDD, cleaned RDD, and then count. And for collect also, it will start from first log lines RDD, error RDD, cleaned RDD, and collect. How to avoid this, right? We need output of one particular RDD to store somewhere, and if we want to use that, means what we should do is we want to cache that RDD. If you are not caching, then every time it will start from the first.
Hello. Yeah, Anusuya.
Yes.
RDD means it will map to each of the file, right? Whatever, how many number of files equals to number of RDDs. Is it like that?
No. RDD is kind of a data structure in Spark, like how we are representing variables as a string or some data structure in Python or Java, right?
Mm-hmm.
Like that, in RDD is one data structure in Spark.
Okay, so when we load data from the files, how that is, like we have to define the number of RDDs beforehand?
No. Like based on the actions you are performing, right? Mm-hmm. Say if you are going to just map, then based on the action you are performing, the RDDs will be created based on the logic we are going through, or based on the logic we written, right?
Okay, so that those RDDs will be created, means like number of RDDs we cannot control.
No, we can't have control over that.
How would we know that that RDD is one of the RDD is not having any data, so we need to coalesce?
So we are not going to apply that coalesce function on RDD. We are going to apply that coalesce function on partition. Say the data is partitioned into 4. We have 4 partitions here. But the data we are having, right, everything will be represented as log lines RDD. That log lines RDD is internally having 4 partition.
Okay.
But for us, it will be looking like only one RDD. You can imagine like, say you are having bunch of books in a shelf, okay? And each that book rack, right, you are calling that as a rack. That rack represents the bookshelf, but inside that bookshelf, you are having multiple racks and storing the books. Like that you can consider.
Okay, so how would we know that one of the partition is not having any data? Like when is the need, then we should go for repartitioning or coalescing?
So while running your program, right, that time itself, there is some command I will show you during hands-on. At that time, you can see like which data is there in which partition. Say you are having 4 partition, either that partition is having data or not. That you can check by running one command.
Okay. Yeah.
If
Thank you.
while running that, if you are not having any data, right, then you can prefer repartition or coalesce.
Yeah. Thank you.
Anusuya, I have one question. So when
Yes.
you initially create an RDD
Mm.
using an externalized data source, does Spark choose the number of partitions, or are you free enough to define like how many partitions you want to create?
We are free enough to define that partitions.
Okay.
We move on to job stage and task. Job is like logic supplied on a RDD. Example, like we are having an RDD object, and we are going to do some logics on that, right? That is what the whole thing is called as logic. Whole thing is called as a job. And stage is like depend on the number of transformations we are applying on a job. For example, if you take this first one, right, rdd object dot map dot filter, this requires only one stage because filter is a narrow transformation. But in the next case, filter dot group by key, here first one is a narrow transformation, group by key is a wide transformation. So in this case we need two stage. So the number of stages will be depend on transformations we are doing. If that is a wide transformation, then that itself need one new stage. If that is a narrow transformation, we don't need any separate stage. For wide only we need a new stage. It purely depends on the data shuffling happening, right? Based on that only the stages will be calculated. And the task is like each stage is having task. For example, in this like map is one task and filter is one task. This is how hierarchy looks like. We have one Spark job, and that is having multiple jobs. Jobs are nothing but the logics we are having, right? And each job is having stages based on the transformations we are having. And then each stage is having task. This is how the hierarchy looks like. And the job will be there in driver, and each task will be executed inside executors. So that's all about RDD theoretical part. Now we will be moving on to RDD hands-on. So I will stop here for any questions.
Hi, Anushya. Like how the executors will be doing the job, like whether they will be separating the jobs by themselves, or like is it the executors, how the executors will be doing their job?
Okay.
The same job will be divided, or how it will be differentiated?
So drivers are responsible for splitting up the jobs to executor and making sure that work got completed. So the responsibility is with the driver. Driver only splitting everything to executor.
Okay, so the executors will be differentiated by the jobs, right? Like each job will be independent, and it will be different for each executors. Or
Yes.
is it the same job will be divided among the executors?
It will be different.
Okay, so separate, each executor will be doing the separate jobs
Yes.
based on the driver thing, right?
Yes. Yes.
Okay.
So
So
each executor, sorry,
yes.
each executor will spawn a task to do it in parallel.
Yes, if each executor will run the whatever job assigned, right, will run parallelly.
Okay, into multiple tasks.
Yes.
Thank you.
Okay, let me stop share and share my entire desktop so that you can see the Anaconda Navigator as well. So I hope you all are having Anaconda Navigator installed in your machine.
Yes.
Okay. If you open, right, then there is something called Jupyter Notebook. you have to launch this one. Are you able to launch your Jupyter notebook?
Mine is still installing Jupyter.
Okay. We shall start with this if you are able to open your Jupyter notebook. And I hope you set it up the specific environment while launching the Jupyter notebook. In that, right, you can download PySpark, or I don't know whether you installed this one already, because we set this as a prerequisite. Okay. I hope you all are opened your Jupyter notebook and PySpark installed in your environment. We shall get started with creating Spark context. First thing, before running a Spark program is creating Spark context. This is kind of entry point, like how we are having main function and all, right? Like that, we have to first create a Spark context, and using this context only, whatever transformations or actions we are going to do, right, we can do everything using this Spark context. So first step is creating Spark context. We should set our application name here, and someone asked the question, right, whether we are having the provision to set the number of partitions we would like to use. So that is the count we have to give here, like what will be the partition count. While setting the master, we can say like this is the number of partitions I need, and then set Spark driver host as localhost. And we are starting our Spark context. This is how you can start creating your Spark context. And to stop Spark context, after you are done with logics, right, then this is the command. For now you can skip this one. To stop Spark context, we shall see like what are all the ways of creating RDD. While taking theoretical part, I explained you like there are three ways of creating RDD, right? One is by using this parallelize one, and another one is creating RDD by external data set and from existing RDDs. So we shall see like how are we going to create that one. Let's take an array of integers as a data, and here what I'm going to do is I'm going to use this parallelize function. And here what it will do is it will take a non-RDD object as input and convert everything to an RDD. Here if you see here, the dist data number of partitions is 3. This is because we gave the partition count as 3. And the type of dist data is RDD. And while explaining theory, I also explained like to identify like how the data got partitioned, right? We can use this command distdata.glom.collect. If you use this one, you can be able to see how the data whichever we provided as an input got partitioned among the partitions we gave or we specified, right? In order to visualize that one, you can use this command.
And yeah, so in the real environment, we would not be knowing that one of the partition, like we have to check it in the normal, like in the course of writing code, we have to check that if all the partitions are occupied and then do the collage, like that logic has to be written.
Yes, Vasudha. Yeah. For automatic partition cleanup will not be happening, but cleaning up RDD, right? Unused RDDs. Since RDDs are immutable, say you're using one RDD in your initial phase of your programming, but post that you might not use that one. For cleaning up RDDs, there is something you can specify the configuration named as dynamic memory allocation. You can enable that as a true. If you set that as true, right, then that will be cleaned up automatically. But for partitions, you have to write some logic, or you have to manually write it somewhere.
Oh, yeah, thank you.
Anusha, there is a question on the chat.
Optimum number of data partitions. So this based on the data volume we are having, like the data size you are going to provide, right? So it always the partitions always depends on the size of incoming data you are having. Next one is creating RDD by external dataset and from RDDs. Let's take, there is one example named as data.text. So what I'm going to do is I'm going to read that one, and I'm going to find the word count or lines count. So here, if you see, lines is one RDD and line length is also RDD. So what I'm going to do is from this line, I'm going to apply some logics or going to do some transformations and creating another RDD. This is an example for creating RDD from existing RDD. And first one is an example for creating RDD by external dataset. Here you can specify the data in your local file in your local, or you can connect with any DBs, like any DBs or storage system like GCS or S3, like whatever you want, right? We can load that and create RDD. These are few examples, and then we are having transformations also here. We will be sharing this notebook with you, so you can try all these transformations during your free time. We are having few narrow transformations here. You can go through the notebook during your free time.
Anusuya, I have a question regarding the Spark context creation.
Yes, Nitin.
So when we say set master and we specify the count, I think it specifies that number of partitions to create initially, right?
Yes, yes.
And what does local specify in the master here?
So we are running everything in our local, right?
Yes.
We are not going to create any cluster mode kind of thing. We are going to do in our local mode.
Okay. And spark.driver.host equals to localhost means that I'm running the driver program on my local machine.
Yes, my local machine. Yeah.
And do I need to install Spark first on my machine before starting my
yes.
Spark?
So yes, so in my machine, right, I configured everything. So it started working. In Anaconda, right, you can install Spark as well.
Okay.
It is mentioned in the prerequisite document. Okay.
No, I have a confusion regarding PySpark and Spark. So I remember I created I downloaded a code for Spark using Scala, Before that, I think there was a prerequisite that I have to install Spark also on my machine.
Okay. So the thing is, right, Nitin, if you install Spark, the native language of Spark is Scala. So if you are going to use Scala, then you don't need to install any other things like PySpark. But here we are going to use Python, right?
Right.
That's why we have to install PySpark separately.
Okay.
What about for Java-based applications?
Java based, not sure. We haven't tried using Java. We are using only Python. Okay. So I'm not sure about Java one. So that's all hands-on I'm having. So I'm handing over to Pravitha for the upcoming slides.
Okay, so shall we start after 3 minutes break, or shall we start right away?
If anyone needs break, then we shall take a quick break and then we shall continue. Otherwise, we shall continue now itself. Rasudha, if you are talking on mute.
I can continue. It's a 2-hour session, right? Only. Yeah.
Okay. Okay, I'll go ahead and share my screen. Hope everyone can see my screen. Okay. So until now, Anushya showed us like what is big data, what is Spark, and how this RDD works, and what are the some of RDD operations, everything. So RDD, using RDD, like we can efficiently process both the structured as well as the unstructured data. So similar to RDD, we have another Spark API that is called data frames. So this is mainly used to process like the structured and semi-structured data. So now we have a question, like we already have a API for like RDD data structure and Spark for processing these tasks. Then why we need data frame? So to come into that, first we can check what are the limitations of RDD. Okay. So first is the RDD does not have an optimization engine. So why we need optimization? So we need optimization so that we can make our work or process more efficient and use a less number of resources. So Spark give us some built-in optimization engine, some automated optimization engine like Catalyst optimizer, Tungsten execution engine, all of these things. But our RDD does not have any provision to use this optimization engine. So if we want to optimize our application, we need to optimize it manually. We can't use any of the built-in optimization engine. That is first limitation of the data frame. Second one is RDD does not provide the schema view of the data. Okay, so we said that it can efficiently execute both structured and unstructured data, but like while we doing structured like data operations on structured data, right, we need the schema or the structure of the ingested data. So we need like what will be the each column or each row will be meaning. But our RDD does not have a provision to like infer the schema from the ingested data. Also, like it cannot, if we want to impose a schema or a structure to the ingested data, also this RDD cannot have a provision. So mainly this RDD cannot manage the schema of an ingested database. Third one is overhead of garbage collection and Java serialization. So RDD is stored as an in-memory JVM object, which is subjected to like garbage collection and Java serialization. And it is expensive because we need to send like both the data and the structure of the node, this structure, because RDD cannot infer the schema, right? We have to give this things separately. That's why it is expensive, because if the Spark want to share the data between a cluster, or if it want to write the data to a disk, right, it will use this serialization. So what serialization means, that it will convert an object to like byte stream to perform the transformations, and it can be converted to back to the copy of the JVM object. So in our data, like for each row, like we will be needing to create this Java objects, and this creation and the deletion of this Java object will be lead to the overhead of garbage collection. So because of this, we have another database, another data structure or a Spark API called data frames. So data frame is a Spark API which can be used to process the structured and the semi-structured data. So it is a distributed collection of data that is organized into named columns. It can be say like it is similar to the tables in our relation database, and it is also similar to some of the like the structure data frame in the R and the Python language. So this data frame have the same features as that of like if it this data frame prevails over the RDD by some means, but it still uses the same features of RDD. So some of the same features it has immutability, resilient, that it can work in even in the like the if there is any issue occurred, then in memory, and it's also distributed computing. So this data frame too, we can create the data frames from different types of sources like structured table, structured file, external databases. Also, we can use the tables from Hive and also from existing RDDs. So this creating data frames from the existing RDDs, and also how to impose the RDDs we can see when we are when we are go on for our hands-on session. And we can like in the RDD limitation, we said that it cannot infer the schema or impose the schema or manage the schema, right? The data frame can impose and infer, like it can get the structure of the data from the ingested data, and also we can impose a structure into the data set, like the ingested data using this data frames. So when Anushya showed the Spark ecosystem, we have seen a lot of languages that are supported for the Spark. So the data frame is mainly available in languages like Scala, Java, Python, and R. And Python and R. Next is so in RDD we will be, I already said that it is stored as a JVM object in memory. So what is the problem is that it will degrade the performance when the memory of like when there is less memory to store RDDs. But in like in the data frame, we will be storing it as off-heap storage. Off-heap storage means it will extend the in-memory outside of that our off-heap store. Okay, and this is not subjected to garbage collection, which means garbage collection, so that it avoids the garbage collection cost. And since it is formed like in the data, it is stored in a binary format, so we can directly perform transformation on this data. Last one is one of the feature is using catalyst optimizer. So I mentioned about this in the limitation that we in Spark, we have some built-in optimizations like catalyst optimizer and text and execution engine. So this catalyst optimizer is uses the standard features of the Scala, like pattern matching. So we know that the Spark is built on Scala language. And this catalyst optimizing depth have some trees and some rules and also some libraries to perform that like queries on this relational databases. So this catalyst optimizer is mainly used to make the Spark applications memory and the CPU core of the Spark application more efficient. Okay, next we will be going to hands-on exercises. That's it about data frame. I will be stopping here for any questions. Okay, I take it as a no. So yes.
So partitions still will be there.
Yes.
Behind the scene, the partitions still will be there for data frames.
Yes, yes.
Thank you.
Okay, so we shall go on to the hands-on sessions. So in hands-on sessions, what we will be covering is to creating data frames from the different site for formats like from CSV, JSON, packet files, and also creating data from RDD. Then how to infer the schema from the ingested data, and also how to impose the schema. And we also do some select, filter, some of the data frame basic operations, and how to run the exact SQL queries on this data frame. So we will be covering. At last, we have 2 example problems. We can cover it. Can also cover it that one. Okay. So in the document, right, I have shared, there is a name called the data frame 1. You can open that data frame 1 Python notebook in your we will be doing the hands-on on the next one. Hope everyone have opened the data frame 1. Okay. Maybe go back to the slideshow. Okay, so before starting the Spark, right, the Spark session is the entry point into like a Spark. So this Spark session was introduced in the Spark of version 2 of the Spark release. And this Spark session, what we'll be doing is it will create RDD. We can create RDD or data frames. There is also another one called data sets using the Spark session. So there is a Spark session object called Spark that is available in the Spark shell. So to run a Spark, we need to call this Spark objects. These Spark objects can be created by using the build-up pattern. That is the build-up pattern. Sorry. And next one is master. So as previously said, we have like lots of mode of running, like the cluster mode and also the standalone mode. So if we are running on the cluster mode, we can specify the cluster name inside this master. So the most will be like Yarn, Mesos, Kubernetes will be the examples for the master. And this local of X means like if we are running on the standalone, right, this X means the number of partitions, or it can be also said like number of core CPUs we are using for doing this Spark job. The app name is if we want to give a name to our Spark session, we can give the name in the app name session. And the get or create, what it will do is if there is a already there is a Spark session, then it will get that Spark session, or otherwise it will create a new Spark session. Okay.
I have a question here. In Spark context, I remember we also defined that the driver would be running on my local, or would that be running on the cluster, right?
Yes.
Do we have that option in Spark session also?
Yes. So this master means, right? So if we are giving, if we are running it on the cluster, instead of this local of X, we will be directly giving the cluster name.
Right. But if we go back to the Spark context statement there, like we had a master where we defined that we are running that on local.
Okay.
And then we also defined the driver location also there. Like there were 2 locations mentioned there.
Nisha, could you help me like which is?
Yes, Pravi, that is in hands-on. I did not specify it here.
Okay.
So that is optional one, Nitin.
Okay.
If you specify that as a like we are running in local, right? Then by default it will take that local host.
Okay.
I just
and if we are not defining, then that will be the driver will also reside on the cluster, right?
Yes. In local mode, right? Everything will be in local host.
Yes.
If we specify as a cluster, then the driver will be at that time. We have to specify either the driver will be there in client mode or cluster mode, but in local we don't have any other option, right?
Okay. Okay.
Okay, 1 minute. Share my screen. Okay. So now we can go back to the Jupyter notebook. So we can import the Spark session from the SpiceSpark SQL package. So first we can run this to start the job. And this Spark session builder.app name. So I have given my app name as data frame basics, and I'm using the get or create. So here I'm using the local itself. So I'm not specifying anything about a master, and I'm not specifying anything about the partitions also. Okay, this also we can run. Okay, it will take 1 or 2 seconds. Okay. Okay, so this error we can skip. This is because of the Java dependency. So if we are using Java 11, we will be getting this one. And if to remove that, we can use the Java, I think 8. That Java dependency shows this error. Okay, so first we can go to how to create data frames. So here we will be taking an example of CSV. So we can create, like we can read the data from different types of format, like mainly CSV, JSON, and Parquet. And the Parquet will be the default one. So there's Spark. Inside the Spark object, we can call this read method to read from a particular format, and we can read it by using 2 formats. First one is .csv. So if we are using the .csv, we can directly give the file name. So here I am giving the same file in my same folder. That's why I'm giving the just as a name. Otherwise, we have to give the exact path. Okay, we shall run this. Okay. This will be the one. And we can also read the file by using the dot format. So in this what this dot format means that it will specify like what will be the type of file we'll be reading, and first we have to specify the format, and then we have to load the file. So these two we can use to try to read a file from with any type of format, mainly CSV, JSON, and Parquet. So if you want to read a JSON file, I can give here it as JSON, and in the format also I can give it as JSON. Okay, it will be same as that of the read format. Okay, so we can see the data. So the data I have provided here is it is CSV one, like it have user ID, name, age, and friends. So I got it as this show means, right? It will show the data. It will show the data frame in a data frame itself is a data structure with the named columns, right? It will show it in a row column format. So I'm getting the data like as in a table manner. But one thing we can see here is that the heading itself is taken as a row, but I don't want that. They have created like column with default names, and columns names are coming in the data. But for that, I don't want that to happen. I want my header in the column name itself. For that one, we have another option. Read dot option. So what this option means is it will take some key value pair and to parameterize to get how to read a data. So it will be a key value pair. If I give header equal to true, it will tell the data frame that we have to show the header. The header is in the data, and we have to show that header as the column. If it is not given, it will be taken false as default. If someone is having any questions, they can put it in on the chat or ask directly. Okay. So I'm running this one. So what I'm doing is I'm giving the header equal to true, and I'm printing the data frames. Okay. Now the header is coming in the top session, that it is coming in as a column. Okay, nice. So we have a table with columns and row and with the named columns. Okay, now I want to, so to perform operation, right, I need to find the schema or structure of the column. So I need to know what is this first column, what is the data type of the first column, what is the data type of the second column, then only I can perform the data frame operations on this. For that, as I said in the, like while we were seeing the presentation, we can infer the schema as well as we can impose the schema. First, we will be seeing how to infer the schema from the ingested data. So in the option itself, we have another key value pair like infer schema. So if we give the infer schema, right, it will tell the data frame that we should get the schema from the ingested data. So I'm giving the infer schema as true. And to print the schema of a particular data frame, we have to give data frame dot print schema. So I am printing the schema so I can hear that. So, okay, here I haven't given the header equal to 2. So if I give the header equal to 2, the header will be coming here. No problem. So here it is saying the first column C0 is string nullable equal to true. That is, we will not be having any null values. And the C1, it is also a string. C2, it is also a string. C3, it is also a string. Okay, so they have tell that like in every column, they are storing the data as string type. But I want to do some operations on this data. So I want the friends as integer type and also the user ID as integer type, right? So for that, what we need to do is we need to impose a schema. We have to create a schema and we have to impose a schema into this data frame we have. For that, we can create the schema using, I have run this. For schema, we can create the schema using this struct type and the struct field. The struct type and the struct field can be imported from the PySpark SQL dot types. So what this struct type is a list of struct field. This struct type represents a row of the data, okay, a row data. Okay, a row of a table. Okay, so this is what a struct type means. A struct field means it represents each column. So it will be a struct type will be a list of struct field, and each struct field he will be having what will be the name of the first column, then what will be the type of the first column, and what will be the whether it is nullable or not. So I am giving that first one will be integer type, and the second and third one will be the string type, and the last is an integer type. So we have the schema here. To impose the schema, we can use another method for this from this Spark read, that is schema. We can just use this method and we can directly give that schema we have created, and we can print the schema. I'm printing the schema here. I could see that the first is changed into user ID and the type is integer. Previously, it was a string, and name is converted to string, age is converted to string, and friends is the number of friends this person have. So we'll have 385 friends like that. Okay, so I have the data. Okay. Moving to next one. So while like this,
I have a question on this one. So if you're defining a schema externally and the data does not match as per the expectation, do we get an error, or does it treat them as nulls? How does that happen?
it will give us an error.
It will give them as an error. I saw, I think, can we scroll up? I think. So if we see, I think the location where we defined our own schema using struct type.
Here itself.
Here itself, right? So here we defined user ID as integer, rest as also integer. So I think when we are reading the file, like we haven't defined that we have to ignore the first row as header, right? We haven't defined that. And if we see the first row, I think user ID is marked as null. Friends are marked as null. So I have a confusion on this one.
User ID are marked as null. Can you come again? I didn't get the question.
So we have defined that friends is an integer type, user ID is an integer type, right?
Yes.
Now, while reading the CSV, I think we haven't defined that we have to ignore the first row, because first row is also uh, uh, defining the schema, right? It is actually not the data.
Okay. So, I missed to say that. So if we are defining the schema, like it will actually read the first one as the header.
First one as the header, okay. But I think it is treating that also as data here. If you see, user ID is marked as null. Friends are marked as null in the first line.
The data type is not matching, it is putting it as
Nulls. So does that mean that if there is invalid data, it doesn't?
will infer it as null.
Yes.
Okay.
So how could be the JSON type data will fit into this row column data frame?
For JSON data, like we have to we will be giving it as a key value pair, right? So
Yes.
key will be the header, like the column name, and the values will be the this one. We can give it as a list, key list, like that.
Okay.
Okay, moving to next one, creating data frame from RDD. So while we specifying about the features, we said that we can even create data from RDD. So to create data frame from RDD, right, we have two df functions, and also two create data frame function. First, we can go through each one. So here I am creating a list of tuples. So this means I will be having two columns. First one is finance, and the second one is the okay, second one is the department. Okay, I'm giving a department name and a department ID. Okay, so this is a list of tuple, and to convert it into the RDD, we are using the parallelized one that Anusuya already mentioned before, and I'm using the RDD collect. So I have an RDD like this. So first, to convert to RDD, we can use the 2df function. So this 2df will be converting the RDD directly into the data frame, and we can see like what will be the schema using this one. So this truncate equal to false means like if we have a lot of data, right? The ID itself will truncate it into like a some number, like number of 20 number, like some rows, like 20 rows. So if we don't want to truncate it, we can give the truncate equal to false also. Okay, first we can run this. So okay, for that I want to run this data frame. Okay, so so what it does is it converted into a row and column format, and the first one is finance, and the second one is like data. Since it doesn't contains header, right? It actually we doesn't have any, like we cannot infer a schema in the RDD, so we cannot give like impose also a schema in the RDD. So here we directly use the RDD to DF, and when we print the schema, like there is no header, and like they given some name as 1 and 2, and the type they infer the type as string and long. Okay, now, but I want to, since there is no name, right? I want to like give the names to my columns. That is my data frame columns. For that, we can actually we can create a list also, like for each column. So since like I'm having tuple, right? It means I have a two columns. So here I'm giving each column a name, and I'm using that name list of names in the 2df functions. So if I run this one, we could see that a department name and department ID is coming. So this is 2df functions and simple. Sure.
Pravitha, could you repeat what truncate equals to false indicates? Like I could not get that.
If there is a lot of data, like hundreds of data, right? Like if we are running it in the ID, like normally we can see that it will take truncating it at, like it will only show the first 20 rows or first 10 rows. It will truncate every other rows.
Okay. Thank you.
If we want to see everything, we can give truncate equal to first.
This RDD feature with the data frames, when is the use case we would be using it? Is it like kind of fetching data from database we would be using it? Like for data frames, we can directly connect to the files for that format, right? And get the data. So where will be the use case wherein we'll be using RDD to convert into data frames?
Not sure about the RDD. Like if we are having if it is in a case like we only have an RDD, like we already created an RDD, and since we already have this RDD, we don't want to get the data from the CSV. It is like an option only. Like if there is also an RDD, we can also get the data frame from, like create a data frame from RDD. Like it's
Can we directly create the data frame from database connection, or do we need to go through the RDD only? If we want to fetch the data from database, in case.
we can directly connect using that.
Data frames only. Data frames can get the data from database and we can start processing.
Yes.
Okay.
So the thing here, right, RDDs are not efficient. Comparing to data frame, RDDs are slower in the performance. So that's why the data frame is there, and internally, like even though we are using data frame, internally Spark will convert the data frame to RDD and optimize it. But if we directly read everything as RDD, then optimization is not there in place. That's why people are preferring data frame over RDD.
Do you have any example of directly connecting to database? Is there anything like directly getting data from database into data frames?
So of now, I haven't included in this one.
Okay, yeah, that's okay. I'll get in touch later.
Sure. Yeah. Thank you. Yeah. Moving to the other method, like similar to 2DF, we can use this create data frame also. So this create data frame, like we can do in the create data frame, it takes two attributes. First one will be the RDD itself, and second will be the schema. So schema here we can give the schema as the direct one, like we can just specify this name, or even we can impose the schema using this create data frame. So first I will be running how to be getting the schema just by changing the department name. It will be same as what we have done in the 2DF. Second one, I will be imposing a scheme, creating a schema that is department name and department ID. And I am imposing that schema using this create data frame. So this create data frame can take both RDD and the schema. Schema can be like we can impose the entire schema structure, or else we can just impose the name itself. Okay. So here we can see that previously we are only in the first case, when we were giving the list of column names, we were not changing the schema of the column, like the type of the schema. But if we are imposing a structure using the create data frame, we can also change the type of the structure as well. Okay, I think if you have any questions, I'll check in the chat. Okay. Anusuya have shared how to read directly from the database. Okay, so now we can move to some of the operations. Select, first one is the select. This select is the same as that of the select operation that we are doing in the SQL operations, right? Like what we will be doing. The select means we will be selecting a particular column from the entire table. So here what I'm doing is I'm setting the header as true and I'm inferring the schema. Then I am using the select function to select the name. So here we are using the fig 100, this database, this data set only. So here what I'm doing is I am selecting only the name. So I can select only the name using this select of, in quotes, I will specify the column name. Or else we can specify the column using the dot operator. We can give the data frame name dot the column name. So what I'm doing here is I'm selecting, I'm printing all the people, I'm getting the data from the data frame and printing all the people's name. And also like I want to make everyone 5 years older. So I'm making it as people dot age plus 5. Okay. So while I'm running, I could see that the name and as well as the age is getting incremented. So here Will's age was 33 and here I'm only getting the name and the age, and the Will's name is changed to 33 plus 5, that is 38. Okay. Similar to the select function, we have filter. This filter function is to filter out a particular column and filter out that is a particular set of rows that like what to say, that satisfies the condition that we are giving inside the filter. Okay, so here what I'm doing is I'm filtering out all the people that is less than, which with people with age less than 21. So I can use here, so I'm printing all the people with age less than 21, and I could see that everyone is age less than 21 only. Similarly, we have a lot of operation, like as we saw in the RDD transformation, right? We have a lot of operations here also. This group by is same to the group by in our SQL. What this group by will be taking is, it will take that group by column and like that age column, and it will group by the age. And then what I'm doing is, so if I do this, right, like if there is a lot of people with 33 ages, so what the data will be like, all like what are the like it will group by each age. So if it will group, if it is age with 31, it will group all the people with the age 31. And then I am going to count like how many people are there for that with that particular age, and I'm going to show. Okay. So this is equivalent to the select age, comma, count star from people group age. The similar as the SQL queries. We are just converting it into a Spark command. Similar to the group by age, we have a lot of functions called the dot sum. Like we can, like you folks can explore more on like what are the operations that are available on data frames. We also have sort operations, sum operations, like that. Okay, so one thing is like here what I'm doing is I'm grouping by age, and then I'm summing the friends of the peoples with that age. So here what I am doing is like the Will's age is 33 and he have 385 friends. So what will I do is I will group by all the people with 33 age, and I will find the sum of the friends with age with the people having age 33. Okay, that is what I'm doing here, and I'm sorting the people age. But here we can see that some like that operation itself is coming as a column name. But I don't want that. I don't want a column name. So to like provide a particular column name as per our choice, we can have another function called dot alias function. So here what I'm doing is I'm selecting the people name. So I'm selecting the the second column, people name, and I'm renaming that column to another name using the dot alias function. So this alias can be inside the alias, we can give the new name. So here I'm giving the alias function. I could see that the column name was previously it was name, and it is renamed to friend name. Similarly, we can have some other function also. This aggregate function is similar to the add function is similar to the aggregate function we have. What if like if we need to do a lot of operations, right? Lot of operations in the same column, then we can use this aggregate function. So here, what is that? I need to find the sum of the friends and also the minimum number of the friends with that with the particular age group. So I am running this one, so I could see that that aggregation function happened, and for a particular column itself, I am performing multiple functions. Okay. Stop here for any question before moving to next session. Okay.
What are the operations that cannot be handled by data frame, or is there any limitations on data frame?
Data frames can perform like the same operation that we are doing in most of the operations that we can do in SQL itself. So actually, you can go to the Apache Spark SQL. Okay. Spark frame operations. And you can go here and find the lots of operations that it is actually doing. So in the Apache Spark itself, it is telling about the like what are the operations. So mainly it can do all the operations that SQL
Basic SQL operations.
SQL can do. Yeah. Okay. So we were talking about the SQL itself. So I want to run the SQL itself. Like I don't want to use any Spark functions. For that, what I will be doing is we can register the data frame as a temporary view. Like as we can create a temporary view, and we can perform the SQL operation on that temporary view. So to create a temporary view of the particular data frame, we can use people dot create or replace temp view, and we can give a name of the temporary view of our data frame. Okay. So here what I'm doing is I'm creating a temp view called people data, and I'm using the spark.sql function to call a SQL query on that people data view. So we can run like any queries by using this Spark SQL fund. But what we noticed before we are running this SQL, we need to create a temporary view of the data frame. Okay, that does pretty much hands-on exercise for the Spark SQL. I have a question. I have a problem here. Will tell what is the problem. So here we have fake friends, right? What I want to do is I want to go, like find the average number of friends that each group have, like each age group have. So here in the data, I am taking the first one. So for the age group 33, I have here 2%, that Will and Gunan is there. So I have to find the average number of friends that this particular age group have. So the value will be like 33 and 229.5, which is 385 plus 74 divided by 2. This is the problem statement. If you folks want to try it, we'll give you 2 to 3 minutes, and we can discuss about the problems then, like problem answer. We'll stop here for Fox can try it. Okay, we have some time constraints, so I will be standing here. So did anyone try it out and want to share the screen for showing answers? Okay, so I will share my screen. Yeah. So it is simple. We can go one by line. So first, what I'm going to do is I only want the third and the fourth columns. So first, I will be selecting both third and the fourth column from the data we have available. And to find the age people with average number of funds per age group, what will I do is first I will group the people by age, and then just simply we will find the average of friends. So we have done a similar thing in the top, like finding the count of friends that a particular age group have. It is similar to this. Only thing we change is we will be finding the average one. So the output will be like this. But we can see that there is no format here, right? So actually I want to sort this one. So I will be sorting this one. These are extra commands only. So I will be sorting this one. And okay, I have sort, but still it is not good, right? So what I will do is I will change this average friends, and I will change this, and I will round the values to 2 decimal places. For that one, we can use the round function. But here it is a difference. So I will be using the aggregate function to find the average, because it is on a same column, right? We will be using the aggregate. But here we could see that we are using something different, like func. So this is a function. This is why we are calling this as like the Python also have some built-in functions, like built-in libraries, like some average, and the Spark also has the similar type of like functions. So if we call this right, like it, there will be an ambiguity, there will be a confusion of which like whether the Sparks one should be used or the Python should be used. To make it more clear, we can use this function. It can be imported from the PySpark SQL, and we can call the function using that PySpark Spark itself, using this function dot round or function dot average. So here I'm rounding the function of average to 2 decimal places. And at last, we know, like while we running this, it will be coming something like okay, something like this only, like round of average of friends. I don't want that. I want to give more meaningful name, like friends dot average. So I'm using the alias function. Okay, so that's it. There is another problem also. You could if you want to more explore on this operation, you can solve this problem. The answer will be available in the data frame 2 notebook in the folder shared. Okay, now we can move to, if there is no question, we can move to the last part of our session. Sure, moving to next part. Okay, so running Spark on the cluster. So here we will be using the Data Pro cluster from GCP to run a Spark application. So we will be demoing it only. Like if you folks want to do hands-on, if you have a GCP account, you can do, or if you want to explore more, there will be a free trial for that will be available for GCP account. You can get that free trial and perform this one. So we are not making this like on to go, like hands-on, because the running the Spark cluster will be taking some time. So we don't have much time for our sessions. That's why we are going this as a demo. Okay, so the running Spark on cluster, we will that this is already mentioned by Anusuya. So the Spark is built on like native language Scala. It has some libraries like Spark SQL to run the Spark query, Spark streaming for running streaming types, MLB for machine learning, and graphics for graph processing. and it can be run in cluster mode as well as in standalone mode. If it is, we can use the Spark standalone mode, or you can use the resource manager to run using Yarn, Mesos, and Kubernetes. So today we will be using the Data Pro cluster, which is running on the Yarn. Okay. So before going to the GCP, like our demo, right? Like some of us will not be like doesn't have much info about like knowledge about this GCP. So we will be covering up a little bit about what is this each, like some services that we are going to be using in our demo. So first one is BigQuery. This is a fully managed enterprise data warehouse to manage and analyze data for machine learning and also for analytical purpose. It is incredibly fast that it can store billions of, it can run billions of commands in a second, and it is very inexpensive and it is easy to use. Okay, so other service we are going to use is cloud storage. So this is a unified storage object service format. It is more like a staging area to store the data from while doing the app doing computations in some like in other GCP services. In the cloud storage, we can store binary large object with any format, and the cloud storage is a persistent storage. So if we are running a computing engine, like computing engine is compute engine is an infrastructure as a service to run the VMs, virtual machines. So we are running a compute machine and storing the data itself in the computing machine, like compute machine. So if the compute machine goes off, the data is also goes off. That is very expensive. So for that, like we can use this cloud storage as a storage area, and we can store it in the cloud storage. So this is a persistent and a durable storage. So in the cloud storage, whatever thing will be storing, right, it will be inside a bucket. And that is like whatever we store, it will be inside a bucket. And this bucket name should be unique because it will be storing in the Google Cloud service storage namespace. The other service we are going to use is Data Pro. So this is the main thing we are going to focus on today more. So it is a managed service for running Apache Hadoop and Spark job, mainly for analysis, for analyzing, and also for doing the machine learning jobs. So it is it is fast that it is can spin up a cluster in about 90 seconds also, and it is cheaper. Cheaper means, so if you are using the Data Pro cluster, is only thing is there will be some jobs. So if we want to run a particular Spark, like we will be creating a job and we'll be running that one. So we only tend to like we have to go on and start the job, and we also just want to end the job. That is to like run a Spark job. But if it is like if we are creating a cluster of our own, right, we have to manage all the services of first starting the Spark cluster, then creating a job, running the job, everything we have to manage. Here we just have to start and stop the job. And it is also integrated with other Google services, GCP services like Google Cloud Storage, BigQuery, Cloud Bigtable, etc. So if you have, okay, I will stop here. If you have any questions, it's already 43. We will have a 10-minute demo. Okay, so we'll go to the next one. Here, what we will be doing today is, like in the BigQuery, we have a Reddit post data set. It is defaultly available in the BigQuery. So we'll be getting this data from the BigQuery, and it will be using this, will be loading this into the Spark cluster. Hosted on the Data Pro, and we will extract the useful information from that the data. So we will get it from BigQuery, then put it in the Cloud Data Pro for extracting useful information, and we will get the data. So to extract this from connecting the BigQuery to Data Pro, right, we have a connector that is provided by GCP called the Spark BigQuery connector. What it will do is it will use some of the APIs that is available in the BigQuery and Data Pro, and it will get the tables from the BigQuery data frame, and it will put post it into the Spark cluster. Okay, so we will be using this. We will be using this cloud, the code labs by the Google services itself. So here they are explaining the how to run a simple cluster very easily. So we'll share the link with you at the end of this demo. I think all you can just to go and Google on, and you will get this code lab one. Okay, so I have a GCP project. So if as I said, if you want to go on and explore more, there will be a $300 credit free trial, which can you can use and you can sign up on. You can explore on this one. Okay, we shall start. First one is creating a project. So I have already created a project. If you want to create a project, after starting the Google Cloud, right, there will be an option called the select a project. If you have already have a project, you can select the project, or you can use the plus symbol to create a project. You can directly give the project name and your projects will be assigned. So this we can do we can run the Spark cluster using the UI as well as in the gcloud command line. Today we will be following the gcloud command line. Okay, so first one, we have to activate the Cloud Shell. So for that command line, I will be using the Cloud Shell. It will take some time if we haven't used this open this cloud terminal for some time. Okay, let it run. By the time we can explore other things. So whenever we need to use a particular service in the GCP project, right, we need to enable it. So if we are using the UI, we can directly go and click on, there will be an enable button. We can click on that enable button. Or else if we want to enable it using the command line, we can use this gcloud service command line. So here what I'm enabling is I'm enabling a compute engine, then data pro cluster and BigQuery storage. This compute engine is, as I said, is an infrastructure as a service that used to run the VM machines. Okay, so I have already, due to the time problems, I have already enabled all of these things in my project. The next one is, so to start with the command line, right? First, we need to set the project. So the project set the project ID. The project ID will be different from the project name. So we can get the project ID by clicking on the project. So if we click on the select project, right? So here we will, if we click on this project, we will be getting the project ID like this. So here for my Spark project, the ID is Fiery Celebrity. Okay, so then we can set the project. But here we can see that my project ID is Spark Demo 9AE6. So it is already set. Then I don't want, then I don't need to run the command once again. If it is not set, we can set our project by using, so using that command. And before running the cluster, we need to mention which is the region we will be using. There are a lot of regions we can use as US Central one, then Asia, like that. We have a lot of examples. So I will be using this US Central one only. This is the default one. So before running the data proc everything, I will be adding my I will be setting my cloud region. Okay, we'll be setting it as US Central 1. It will only take a second and that is updated properly. Okay, nice. And next is to create the cluster, right? I'm creating a data block cluster. So one way is we can create an environment variable and we can create give the cluster name, and we can use this cluster name environment variable in every place we are using. Or else we can directly give the cluster name in the command itself. So I am going with the directly giving, or if you want to first create an environment variable so that it can be used in multiple places, you can go with environment one. Okay, now we will be creating a data pro cluster. So to create a data pro cluster, we have to use this following command. So here I will be using this data pro clusters create function, and the first one will be the cluster name. So the cluster name, it is our choice. We can give a unique name. So in a project, if we are using the same name, it will throw an error. The worker machine type. So as Anisha said, there will be masters and workers, right? Like the drivers and executors. So this executors machine type, we can specify explicitly. So here I'm using this N1 standard, like in here they are using N1 standard, right? Like depending upon, like we can go and check what are the worker machine type for the data pro cluster, and we can choose the worker like machine type. It will be based on the GB used, the memory, the CPU core, everything, CPU, memory, everything. So we can go on and check like what will be suitable for our use case. This num workers is number of executors or number of the worker machine we will be having. Image version is the version we are using, like the data pro version we will be using. The initialization action. So initialization actions means like whenever like I am creating a data pro cluster. So I need to perform some actions while creating the cluster itself. For that, we can use the command, this initialization action. So here what I am initializing is, I will show you, I have some pip file. So I want to install some pip commands and all of those things while running the data proc, like creating the data proc itself. So I am, okay, sorry. I am specifying the that value. So to do this, right, first we can this GS means it will be getting it from the cloud storage, and these are like each bucket and the values inside the bucket. So you can create the bucket directly using this, like using the UI, like you can search for GCS storage and you can create the bucket, or you can create the bucket. Bucket is for storage in cloud storage. You can create it using this gsutil command. So I am having this pip install in this bucket and using for it initialization actions. And this metadata is also to include some metadata. If we want to add some metadata in the cluster, we can include. So here I am adding some like that. I have some pip packages from Google Cloud Storage. So I am adding, so I want to add that metadata in this data pro cluster. So I am using this one. This optional command says if we, so previously we were running the Jupyter Notebook in Anaconda, right? Similarly, if we want some additional components, we can specify it using this optional command. I'm not going to do that because this was a previous way of using is. Now we can directly, like we can ignore this one in the latest version. The Anaconda is already in there. And this enable component gateway is used to, if we want to get some ideas on the UIs, like what, like I want to show, need to know like what will be the memory, like what is the using. So some UI data, right? Some UI analysis, if we want to see, we can use this enable component gateway. So this enable component gateway will allow us to create some of the gateway common UIs, that is like Zeppelin, Jupyter, Spark History. These are some of the options available to see the UI for this Spark cluster. So enabling component gateway. So we can go here and we can run the command. So my command is a little, okay, using the same command. This here. So service account. So to run a particular service, right, we will be needing some permissions. For that, we will be giving service account, we will create an account and we will give some permission to that account, and we will use that account to run these jobs. So if we didn't give some service account, it will be directly using our default one. But I don't want to use the default one. I just created a service account of my own. I'm running that one in the service account. And I also have a bucket already created. So I'm using that bucket using that bucket in the cloud data pro cluster using this hyphen bucket. Okay. So I will run this, but it will take some time because of that I have already created this one data pro cluster. Because of the time issue, we can go directly to data proc, or we can go here and navigation menu and we can find the data pro cluster. Okay, I'm going to data pro cluster. I have already created a cluster name Spark Workshop Demo. Okay, this is the cluster I have created. So the cluster creation part is done. Now we need to analyze the data. So to analyze the data, we have a lot of not lot of operation. We have two options mainly available. First, we can find the data using the BigQuery UI and also running a Spark cluster. Okay, so how to get the data using a BigQuery, I will show. I will be duplicating this command and I will be getting the BigQuery UI. Okay, while it runs. So in the BigQuery UI, as I said, we can also get it from the navigation bar here. Okay, so I will be running this command line in the BigQuery. So what it means, it's like I already said, like there is a default data set for the Reddit post in the BigQuery. So I will be using that that data set and I will be getting the first 10 rows. Okay, I can run this in our BigQuery. There is an option to run our BigQuery, run the SQL queries in the editor. We can pause these queries here and we can run it. Here we can see some of the data. So this is a Reddit data. So Reddit post data, and it have a lot of columns like UTC, created UTC, what is the subreddit name and author, domain, and lot of the data. So this is a way of viewing the data that is available. The second way is using our Spark cluster itself. To run the Spark cluster, so we need a file, we need a Spark program to run, like we have created here. So I will be using the Google Cloud one itself. That I will import it here. I will show what is this. Okay, it is already exist. I will show what it is. So here I'm inside so it is a GitHub file. It can be get it from the GitHub itself. It is provided by the Google services itself. Here in the function, in the Spark function, what I will be doing is I will get the data and I will count the subreddits data. Okay, I will get the data for the subreddits one and I will count the subreddit data and I will show the subreddit, like I will group by the subreddit and I will give the each group's number. That is what we are going to run on our cluster today. So this is just cloning the data into our command line, like into our GCP, and I'm going inside this folder because it is the Python file that we need to run us inside that folder only. So I'm going there and we can run the job, data proc job. So inside the data proc, like whenever we need to like run some command, like run some Spark function or Spark file, right? We can run it is using jobs. So for each running of these job, like the files will be as jobs. So we can create a job to run a file. So here we use the gcloud dataproc jobs API. So this jobs API will submit. If we use this, it will create a job in the dataproc cluster. And if we specify, so here I am using the PySpark. Since I am using the Python file, I am using the PySpark. So if we are giving this PySpark, right, we can have a method to give the cluster. So I have, like, if I have more than one cluster, so we can, like, I can select what is the cluster I'm going to use. And this JARs means it will allow us to use the connector. So here I already said that we will be using the Spark BigQuery connector. So the Spark BigQuery connector is defaultly provided by the Google, and it will connect from the data frame to our Spark cluster. So that we can connect using this jar command. And the other one is driver log levels. This is like if we run the Spark program, right, we could see that there will be a lot of logs, but I don't want to see all of these logs. I just want the log output. So I will be using the driver log levels like the root funnel, which will suppress all the log output except for some errors. And at last, I will be running the count subreddit.py. Okay, so we can run this one in our command line. This also will take, okay, not, I have been provided the sub cluster name. Okay, it will take about 2 to 3 minutes. So I have already ran a job before to show you like what will be the output. The output, we can get the output in the command line itself like this, like it will give the subreddit and the amount of that subreddits count. Or else we can see it in our Spark UI. So if I click on that Spark, right, in this monitoring, it will show like it will show in real time, like what is the YAN memory, what is the PEMD memory available, what is the CPU utilization during this time, and all of those things we want to know. And also here it will show the output also, since our Spark job is running only, right, it will take some time. So I have already created I have already run the same function with a different job. This already succeeded. So here I will show you what will be the output. So in using the UI itself, we can check what will be the output. So here we can see the output and all the what are the things that Spark cluster have been doing. So after this command is successful, right, we will get the data for the current job that we are running, like this one. So we could see that our job is running only. Okay, our job is running. Similarly, like before saying here, like while setting up the environment, I told you that this enable component gateway will provide some of the UIs, right? One of the UI is, these are the some of the component gateway that are available. We can use each of these to show, like view the details of that one. So here I'm using the Spark history server. So this history server will show like all of the jobs that have run in that particular cluster. Similarly, like this will be only available if we have enabled it while we are creating a data pro cluster. If we use this command only, then these UI options will be available. Okay, I think that is pretty much. So we can see the UI using this. So here we use the gcloud command line. We can use like create or submit a job using the UI also. Here we need like the data we provided here, we need to provide the data here also. That is the difference. Okay, any questions? I think we are 4 minutes after the time.
How to save the data to CSV after, like we are just doing .show, right? So it is performing show action.
Okay, so we haven't covered it in here because our things was to just how to get how to run the cluster. If you see it in this code lab, like there is an option to show like how to, like here we can use some sh commands. So it is available here. So we can try some commands like we have to actually write the logic, and we can run that to store these jobs back to the cloud storage. We can store this inside cloud storage using some of the, like, you can explore more on here. This the ninth step, running your backfill job. Here they are explaining how to convert it into a CSV file and load into a bucket in the our cloud storage itself. So we are only covering until this one, like how to run a cluster on a Spark. We haven't covered how to store back it on the storage. You can explore more. I will share the links in the chat.
Pravitha, can we go back to the source code? Like I see there is a difference in the Spark session creation. So when we write a code for submission on an external cluster, why don't we specify the master?
Okay, so that master means, right, I am running it in my, so here I am like actually running the entire function inside a cluster. So I am like giving this file inside the cluster, so that in that case, that cluster know, right, like this is the cluster, it is running. Okay, but there is some other option. So when like in AD, there is also some other option where like we can start a cluster and we can access that cluster by using our command line, like in our local. So if I am not using this Google command line, but I'm using my terminal itself, in that space, we can connect it to using this master one. So here, since I am directly putting the Spark file inside the cluster itself, we don't need to explicitly mention that it is running on that particular master, like that cluster. So here the data proc knows that it is running on yarn, so we don't need to explicitly specify.
So master is only needed if you need to run a job on an external cluster from your local machine.
Yes, kind of. Right, Anusuya?
Yes, Ravi.
Okay. So that was our session. I think we are 7 minutes over. Thank you, everyone. So over to you, Gayatri.
Yeah. Okay, so people, I have shared a link for the feedbacks actually. So maybe take some 2 minutes of time and ensure that you feel like what is with what you learned in this session, and like what went well and what has to be improved for this session, in like for the future session, what has to be improved. So it will be helpful for our us also. So please take 2 to 5 minutes of time and fill those things, and feel free to drop the call.
Just a question, like what kind of opportunities we have in related to this big data?
So you are asking about opportunities related to big data, right? Hello.
Yes, like the job kind of thing in the yes, kind.
Like, yeah. So currently, like, so there will be in the future opening for data scientist, data engineer stuff, and you can always see through our ThoughtWorks for job portals for those kind of openings only.
There is a lot of openings for data scientist and engineer. We can check on the career page, ThoughtWorks career.
Yeah, sure. Thank you.
Yeah. Please do fill the
Also, we'll be
feedback.
having this recording.
Yeah, continue.
Yeah, sure. We'll be getting session, right?
Yeah, so we are planning to upload this in YouTube actually. So if even if that is not possible, we will try to share it over Drive or something. So most probably we will from this session we will be uploading it in YouTube. So maybe in this week we will upload it and we'll share the link for it through mail or update in the
Yeah.
meetup post.
Okay, fine. Thanks.